Okay, so today we're going to run through our skills practice sheet, see how far we can get. You should be able to move very fast with these. You need to practice them though. We have been practicing some of these skills in class already, and then we're going to get to some new skills that we need to practice. They're very important for us, okay? Make sure you remember about, I'm going to go quickly here, but about polynomials, etc. There's a difference between a polynomial and a polynomial with only one variable. We need to get into that in a minute here. But anyway, polynomial would be the mathematical expression involving the sum of powers on one or more variables multiplied by coefficients. So that is a polynomial. A term is any number being multiplied by a power within a polynomial expression. They're each called terms, right? The coefficient would be, let's see, not the exponent. Let's see, I'm sorry, wait a minute. The term is each product in a polynomial expression, right? Now the coefficient is any number that is being multiplied by a power within a polynomial expression. Ooh, I got you the wrong one there. So term is each product in a polynomial expression, and the coefficient is the number that is being multiplied by a power. So if we have like 3x squared, right? X squared is the power, and the number 3 is the coefficient because it is a number being multiplied by a power. Okay, I should probably have checked these answers first myself. Here we go. A monomial is a polynomial with only one term, right? A binomial would be a polynomial with exactly 2 terms. A trinomial, a polynomial with exactly 3 terms. The degree of a term, okay, the degree of a term looks like this, the exponent of a term in a polynomial. That's right. The exponent of a term in a polynomial tells us the degree of that term. The degree of the polynomial is going to be the degree of the term with the greatest exponent. So those are just, we've covered that already, but you should be able to get through that pretty quickly. So now we got to go through each, what are the terms and the coefficients. So here we go, this one right here. The term is 2m cubed, the coefficient is 2. The terms, you have 2 terms, x squared and negative 4x. And here we go. The first term has a coefficient of 1. The second term has a coefficient of negative 4. I have 3 terms, 1, 2, and 3. My coefficients are negative 3, 1, and negative 9. Here I have 1 term, it's negative 18. Here I have 3 terms, 10, negative 3, and negative 6 are my coefficients. Okay? It says determine whether each expression is a polynomial. If the expression is not a polynomial, explain why it is not. Alright, so remember, a polynomial with only one variable does have some rules we're supposed to follow in order for it to be a polynomial. So in this case, it is a polynomial. We have 2 terms here. Now, this is not a polynomial. Why is it not a polynomial? We would say because the exponent shows a fraction. We should not have a fraction as an exponent. This would not be a polynomial either because even though the x is down here, this could be written as 3x to the negative 1. And anytime you have a negative power, we wouldn't consider that a polynomial. And here we have a polynomial. That's fine. This is a polynomial. This is a monomial, but a polynomial. Okay? This one is a polynomial. I know you might say, wait a minute, it's got a fraction again. But this is just x to the 1 being divided by 7 or multiplied by 1/7. So this is 1/7 x to the 1. That is not x to the negative 1, right? So if it's in the numerator, the x is okay. It is a polynomial. It's only when the x was in the denominator that meant that x would have had a negative exponent. So we're fine here. This is a polynomial. Okay, this is not a polynomial because the cube root of x would be written as x to the 1/3, and our rule says you can't have, a polynomial would not be written where you have a fractional exponent. Not in one variable anyway. So here we have a polynomial. That is a polynomial. Alright, so now you just got to know whether it's monomial, binomial, or trinomial, and the degree. So this is a binomial, and the degree is 1. This is a monomial, and the degree is 2. This is a binomial and the degree is 2. This is a trinomial and the degree is 4. Now how am I doing these? Well, I'm just counting the number of terms, right? So monomial, binomial, trinomial, and then the degree, I'm just looking for the highest power. Here's 4, there's 2, and this would be 1 here, right? This is a monomial, and there is no x. That means x to the 0, so we would say it has a degree of 0. This is a trinomial, degree of 3. And now they want to make sure it's in standard form and then classify it by number of terms and its degree. So put this in standard form would be 6x squared plus 2x. Switching it around because we want to put the highest degree first and then go in descending order. That would be standard form. So it is a binomial with degree of 2. So to write this correctly, I would have, or in standard form, I'd have 4m cubed minus 9m squared. It is a binomial degree 3. Here I have negative 5x plus 10, and I would have this be a binomial degree 1. And I would put this in the front, 12x squared plus 7x minus 3, a trinomial degree 2. Here I have negative w cubed plus 4w plus 15, trinomial degree of 3. 5x squared plus 20x minus 15, so I just got to flip these two, right? Trinomial with degree of 2. Negative p to the 4th minus 1, binomial degree of 4. 3t cubed minus 6t squared plus 4t, trinomial degree of 3. Okay, this would be negative 18a cubed minus 22a squared plus 54a, trinomial degree of 3. Negative x to the 5th plus x cubed minus x squared, degree of 5. So just remember the negative signs, these minus signs, they stick with the term, and if I'm going to move that x to the 5th to the front, it's negative, right? Negative x to the 5th. This one here is positive, plus x cubed minus x squared. Okay, now they want us to simplify. So we simplify using the calculator. I'm going to have you guys practice these, get through these sets, right? And so you can pause the video here and do all of the ones that you see on the screen real quick. Okay, running my answers real quick for you. Here I have 2m squared plus 9m minus 6. Here I have x squared plus 5x minus 18. Here I have 4t squared plus 4t plus 9. Down here I have 10w squared minus w plus 3. And then over here I have 3x cubed minus 5x squared plus 8. So there's those. Go ahead and pause and do these next four. Okay, here I have a squared minus 7a plus 7. There I've got 14p to the 4th plus 8p to the 3rd plus 14p squared minus p. Over here I have negative 6x to the 5th plus 3x to the 4th plus 9x to the 3rd plus 3x squared minus 5. And over here I have, let's see, what was that again? 3m cubed minus m squared plus 1. Okay. Alright, so now you've got this graph here, and it says evaluate h of x. So h of x is this function. Evaluate it at x equals 2. So I would look at this graph right here, and I would say when x is equal to 2, where is that graph at? So here we go. It's all the way right here. When x is equal to 2, it's right there. So the value of the function when x equals 2 is 8. Now, how did they evaluate it? Well, you can evaluate each of the other two functions, right? Here's the other two functions. You have this f of x and g of x, and they're saying that this value, this function here is equal to the two of them together. So they just put, they're going to substitute 2 in, or they created h of x, and they just put 2 in for all of that, and then they get 2. 8. But using the graph is pretty simple for me to evaluate it here. X is -4. So where is H when we get to -4 on the x-axis? It's right here. -4, and there's H right here. So I mean, what they're trying to do is just show you that, hey, you can add these two functions together to get to the same value. So that would be like 9 plus, what's this, -7 is equal to +2. That's what they're trying to show you there. All right? And we'll skip by those. We've done some of those already. Just checking out the binomials again and using algebra tiles, right? So when you do x times x, you get x squared. Here we have 1 times x over here is 1x. 1 times x over here is 1x. And then 1 times 1 gives me 1. So the total answer is x squared plus 2x plus 1. So go ahead and see if you can create a sketch of these real quick and do them using the algebra tiles approach. Okay, so I have to have one tile that's x this way. There's x, right? And then a tile that is 1. That's a small tile over there. That's 1. And then this is, we're going to be multiplying it by, I need an x tile this way. All right, the x tile here. Too wide, but whatever. And then I need 4 little guys. Oops, 1, 2, 3, 4. Hopefully you can just sketch these out faster yourself. And then I'm going to switch to a different color here to show the product. The product's on the inside, right? So we make this little rectangle here and we say, we want to find the area here. So x times x, that'd be this big guy right here, and that's x squared, right? And then I have 1 times x, and that's x. I'm going to bring this line down here like this, and then I've got to go across like this, right? Boom, boom, boom. These are all x. 1 times, this is 1, 1, 1, and 1, right? These are all 1s. So 1 times x gives me x. 1 times x is x. 1 times x is x. So that's the area of these little rectangles. And I have 1 times 1, so these are 1s. 1, 1, 1, 1. So I add it all up, I have an x squared, right? I ended up with 1, 2, 3, 4, 5x, so plus 5x. And then I have plus 4. Now remember that that's a model for you to do them by hand. How do we do them on the calculator? Well, right here we're taking two binomials, we're ending up with a trinomial, we're expanding it out because we're multiplying, right? We're multiplying across, so we're expanding it out. So another way to do that is to put it in the calculator as expand. So that would be, turn your calculator on and go down, say menu, algebra, and then 3 is expand. And then just make sure you put inside parentheses each of those binomials. So x plus 2 times, and parentheses again, x plus 2. And then you can hit enter, and this would be x squared plus 4x plus 4. And this one is going to be x squared plus 6x plus 9 if you did that, okay? Okay. So multiplying, we've done some practice here. Here I'm going to get 2x squared, and then I'll have x and 7 plus 7x plus 3. Here I'm going to have 2x squared plus 7x plus 6. Okay, if I'm doing that right in my head. And here you can see a multiplication table. So we don't make all the x's and everything else. We just make a table. 2x times 3x gives me 6x squared. 2x times 4 is 8x. 3x times 2 is 6x. 2 times 4 is 8. And then these diagonals can be combined. 6x squared plus 14x plus 8. So here I'm going to get 20m squared plus 12m plus 30m. So plus 42m. Plus 18. So go ahead and do a multiplication table if you want. You need to be able to read these and do these because on the test they'll show you a couple of these and ask you to figure out what they are. So there's a couple of problems for you to practice with. Okay, this problem here you should be getting 42t squared, and we got plus, let's see, 35 and minus 30, so plus 5t, I think, and then minus 25. Here I've got 16x squared minus 4. Right? 16x squared minus 4 is what you should end up with there. There's a couple more. You can pause this. Okay, and I've got 90w squared plus, let's see, that'd be 80w minus 9w, 71w minus 8, right? And this would be 5y squared plus 60y plus 15y, so plus 75y, right, plus 180. Now we're distributing. When you distribute, you think about bringing that 2x in and multiply it times the x and multiply times the 6. So 2x times x is 2x squared, and 2x times 6 is 12x. So 2x squared plus 12. So this would be 4x cubed plus 8x squared. Okay, see if you can figure those out that way. Pause that and go. Okay, I've got 7x squared minus 35x. And now I'm going to distribute in. Uh-oh, I've got to distribute in twice. So 2x squared plus 16x plus 1x plus 8. So it's 2x squared plus 17x plus 8. So I have x cubed minus an x plus 3x squared. Okay, so x cubed plus 3x squared minus x minus 3. 20x squared plus 20x minus 20x. So this will be 20x squared minus 20. Right? And 3x cubed plus 15x squared minus 3x. 27x cubed minus 36x squared plus 18x. Okay, take a pause, practice these on your calculator. Remember to use your expand function here. Okay. When we're getting into factoring, we're looking for the greatest common factor to factor out, right? So we can use our factor tool in the calculator to do that. Now I know this is x times x and this is 9 times x, so I know I can pull the x out and I'd have x plus 9. And this is m times m and this is negative 4 times m, so I pull the m out and I get m minus 4 on the inside. So m times m minus 4. Remember, when you do these, you can use your calculator to factor, okay? And when you do factor, okay, what you have to do is menu 3 for algebra, 2 for factor. Okay, you got to put the expression in. So 5x squared plus 20x minus 15, and then hit enter. It's going to look and say, okay, what's a common factor in all three of these? And it has 5 here, 5 times 4 here, and negative 3 times 5. So it's going to pull the 5 out, and you're going to end up with x squared plus 4x minus 3. So 5 is the greatest common factor. Now the trick here is you have to make sure your settings are on exact, right? We talked about this yesterday. Just make sure, well, Friday we talked about it. So make sure that your settings are on exact. And to change your document setting, go Doc, Settings and Status, Document Settings, and then go down to Calculation Mode and make sure it's on exact. Because if you're not going to get an exact. You're going to get a, if you're on approximate, you could get some funny stuff with decimals, right? Okay, so you should practice factoring each of these. Practice factoring each of these. Okay, now it's showing you how you can factor by hand. What you're looking for is you're looking for, how am I going to get x squared up here in this trinomial, right? So you'd say, what am I going to do to get x squared up here? And how am I going to get 3 down at the end, right? So the way to get 3 at the end is to have 3 in one dimension and 1 in the other dimension. You have, the way to get to x squared would be to get x times x. So if you had that, you'd have x plus 3 times x plus 1. So I'm trying to do the same thing. I'm trying to think of how would I multiply to get 6, but add up the x's to get 5. So let me show you what that would look like. So I know I need to have I know I need to have an x squared, so now I'm going to start with the product here. I got to have an x squared, right? 1 though, only one x squared. So that means I'm going to be using an x and an x here. I know I've got to have 5 total x's added on here. I'm going to have some go in this direction, some go in that direction. But I need to have 6 1s also. So what I'll probably do is I'll go over here 3. So I have 1, 1, and 1. Let me draw lines down. 1, 1, and 1. Now if I do that, right, that's going to give me 3 x's here. X, x, and x. So now I end up with x plus 3. And now if I go down 2 this way, okay, about there, 2 that way. I went too far with these little lines here. But let's say that these were each 1s. 1 and 1. So now I've got, and this needs to come all the way down. So now I've got another x here and another x here, right? So that's x squared and 1, 2, 3, 4, 5x. And now I've got to count these ones. So there's 1, 2, 3, 4, 5, and 6. So just to do these by hand, you can look and say, what are my factors of 6 that add to 5? Right? And especially easier, it's a lot easier if I don't have any, if my coefficient here is positive 1 for x squared. Otherwise, you know, if I start to complicate things, if this is some number besides 1. But for right now, it's just 1. So all I have to think about is factoring this 6 in a way so that I get a sum of 5. So what two numbers multiply together to get 6 and then add together to get 5? And the answer is, I would say this actually factors is x plus 3 times x plus 2. Those are my two factors to give me that product. As you can see from my little drawing that I did. Now I don't need you to do the drawing. You can practice factoring. We're really low on time in the class, so you can just practice factoring the calculator. But I want you to practice factoring today on the calculator. Okay? So factor that one out. Okay, should get x minus 3x plus 2. Is that what you got? Factor that one out. Okay, should have got x minus 4x plus 3. Factor that one out. X plus 5, x plus 2. Here we go. X plus 4, x minus 1. Okay, now, here we go. Using a multiplication table, they're just having you do the same idea. I will do one with the multiplication table here, but I'm basically looking the same way I did those other ones, just a little bit shorter, especially these bigger numbers. So here we go. I know that in the end, I've got a product that's going to have y squared here and 42 there. 42 little ones. So what are two numbers that can multiply together? Well, how do I get the y squared? Well, that'd be y over here times y over here, right? And then what are my factors for 42? Well, 6 times 7 equals 42, right? And this would give me 6y. And this would give me 7y. And if I add those y's together, I get 13y. So I end up with y squared plus 13y plus 42, which is the trinomial I'm looking for. Again, factor them using the calculator if you want. Okay, x plus 7, x minus 1. How about x minus 6, x minus 3? All right, so here you want to factor that 4 out first, right? So if I put 4, let me do this one. Now notice it gets a little more complicated because I have a number other than 1 right here in this coefficient. So if I start by factoring, to make this a little bit easier, put the 4 on the outside. What's the trinomial that's left inside? Well, I end up with w squared plus 3w minus, let's see, 10, right? Minus 10. That's a 1 right there, sorry. Minus 10. So this is negative 40 divided by 4 is negative 10. All right. So my next step now is to look at this and factor this, thinking, what are my two factors of negative 10 that would add together to give me positive 3? So it's going to be x plus 5, x minus 2. Over here you can factor out the 2 as well. And you can factor out a t, because there is a t in each one of these. So you should have 2t in front, which would leave you with a t squared. Why, it's good to see those common factors. Minus 14, no. Minus 7t. All right, minus 7t, because I divide this by 2t. And then plus 12. Is that right? All right, so my factors of positive 12 that give negative 7 when added together would be x minus 4, t minus 4, t minus 3. So, I should have 2t times t minus 4, and this is just going so slow, I'm just going to say it, t minus 4, close parentheses, t minus 3. Okay? Okay, and again, you can always factor. And you should have, for this one, let's see, we should have, divide this, I get 20, and divide this, I get 12. So I'm going to have 3m factored out times m plus 10 times m plus 2. And here I'm going to factor out the 2, and I'm going to get x squared minus 4x minus 21, right? X squared minus 4x minus 21, and so then that would be x minus 7, x plus 3. Okay. So now trial and error method. This, what they're talking about here is looking at all the possible combinations and thinking about with every factors for 10 and 11. Now this is basically what I've been doing in my head. What are the factors for 10 that somehow can add up to 11? And you see 1 and 10 are the factors for 10, and they add up to 11, so they're going to do positive 1, positive 10. Okay, so go ahead and practice these. If you want to use your calculator, that's fine, and I'll give you some answers here. And I'm doing all these in my head, just so I hope I don't make a mistake. Okay. So the factors here of negative 16 would be w plus 8, w minus 2, because 8 minus 2 would give me 6, right? And here I have factors of negative 35 that add together to positive 2, so it would be m plus 7, m minus 5, those would be your binomials there. Here I have factors of negative 12 that add together to positive 4, so that would be x plus 6, x minus 2. And I'd factor my 3 out first, right? So I'd have n squared minus 9n plus 20. So now that would be n minus 5, n minus 4. Okay, 3 times parentheses n minus 5, parentheses n minus 4. Factor out my 2 here, and I end up with 2 out in front, and this would be 11x, and that would be 30. And so I'd have x plus 5, x plus 6. And here's a whole set of sheets for you to practice, and you can see how just changing those negatives and positives can just really make such a difference here. So I'm trying to get to 28 with factors that add to 11, make them both positive. Trying to get to 28 with factors that add to negative 11, make them both negative. Trying to get to negative 28 with factors give me a positive 3. So I know that negative 28 is, this is what I'm thinking in my head. It's one that's got to be positive, one's got to be negative. And I'm thinking of two numbers that have a difference of 3. So that'd be 7 and 4, the two factors of 28 that have a difference of 3. And I see that it's a positive 3, so I want to use the positive 7 because that is a bigger number. And that will give me a positive 3 when I combine it with negative 4. Meanwhile, when I want to get a negative 3, then I need to make that bigger number, the bigger factor 7, negative, and the smaller factor positive 4, and that's how I get the negative 3. Okay? I'm going to just have you practice those, but I want you to actually take the time to factor all of these. Okay, that's 4, 8, 12. To practice factoring all of those. So you should pause the video now. This is going to take you, several minutes to get through. I want you to do it. Okay? And here's a few more. Okay. So when possible, factor out the greatest common factor first. I see a negative 1 in here, for example. Factor those out. Factor those out as well. All right, now, one of the reasons why do we do so much factoring? Why do we like factored form? Well, remember when we had quadratic equations or functions, when they're in factored form, well, then it's easy to see the zeros. We just say, well, what makes each of these factors a 0? Okay, so we're just thinking about these zeros. Let's take a look right here. It says, factor and solve each quadratic equation. So if I know this is supposed to equal 0, and I can factor it, then I know either this has to be 0 or that has to be 0. So whatever turns this into 0 is going to be one of the roots to the solution, right? So that'd be negative 3 plus 3 equals 0. And whatever turns this into 0 would be another root. So if I put negative 2 here, I would get to 0. So therefore, my roots are negative 3 and negative 2. And then they want you to check them. And this is important to check them because we do have something where we do have extraneous roots. Sometimes it'll suggest they're 0, but you got to check and make sure that they really are. So we check by taking the negative 3 and putting it back in the equation for x everywhere we see x. So there's negative 3 squared plus 5 times negative 3. And we can see that, yes, if we follow through with the math, it gives us 0. Now, I have good news for you. You're probably going, Mr. T, we're overwhelmed. Been doing so much with these polynomials. But guess what? If you were to turn on your calculator and go menu and go to algebra, and you were to go to, there it says 4 zeros, okay. Well, first of all, you can factor it. But let's see if we can use the zeros function. So I'm going to go x squared minus 3x. So actually, let me go back and do the one that's done already. So that's x squared plus 5x plus 6. And if I do comma x when I get done, so I do zeros, open parentheses, and I just put in x squared plus 5x plus 6. And I do close those parentheses. But before I close the parentheses, I put a comma x. So I'm asking, find zeros for x. Find the zeros for x. So this is going to give me the roots for x. So comma x goes inside the parentheses. Okay. So let me see. I'll type that up real quick. Let me see if I can type that up in here. So let me see if I can real quick. I'm going to edit this real quick. And I'm going to add text. So the way that I put that in to my calculator, right, is I can type zeros. Oops. Change the color here so it's black and make the font a little bit bigger so you can hopefully see it. And here we go. So in my calculator, I'm putting in zeros, open my parentheses, then I put in the equation. So that'd be x squared. I'm going to put shift 2 to represent the square, right? And then plus 5x, right? Plus 6. And then I just put a comma and the letter x and close it. Now, if you put that into your calculator like this, right? Only this is obviously using a square button. There's no arrow to, right? So x squared plus 5x plus 6 comma x, you're going to find the roots. And that's how these work. And the roots are the zeros. That's another word we're using for them here. So menu 3, 4 for your zeros, and then put it in x squared minus 3x minus 4 comma x, and you should be getting zeros at -1 and +4. Okay? So we could let you work through and practice finding the zeros, right? Find the zeros. Because whenever you get a 0, that's when the that's the values that you could put in here that would turn the equation into 0. Okay. All right, now over here, notice this is a good one. We're getting to some different ones here. If you look at this, this is not equal to 0. So first, I would need to add 15w to both sides. Then that would turn this into 0. So what am I going to put in the calculator? I put w squared. All right, so my 0 for this kind of a problem, I'd have to know. If I'm being asked to find the roots, I would go zeros, and I would put in the w squared, right? And then I'd go plus 15w, right? And then plus 50, and then I do comma w. All right? And the reason I'm putting plus 15w is because I got to, anything on this side, I've got to move over here. So w squared plus 15w plus 50. Okay? And then that would be equal to 0. I need to do the same thing here. I need to make this equal to 0, right? So I've got to subtract 32 to make it go away. And then what will be left here is 0, right? So my zeros would look something like this, or my command in my calculator would be zeros. And then I'd go negative t squared, right? Plus 12t minus 32 comma t. All right, that's how you're going to put those in. Okay, here are a few more you can practice. Now here I'm going to have to subtract 2w, right, and add 4. Okay, and then I can practice getting my zeros. So I'd say if things are moving fast here, if you guys are flying through this, then pause these videos as I'm scrolling through to make sure you actually do all of these works. All right, it says determine the zeros of each quadratic function. So now, so the difference is, you know, we called these roots because these are not functions that produce a 0. So we called it the roots of the equation, meaning what would make this true to 0. And this is the same exact thing. It's a function, so you don't really solve a function, but you say what would make the output equal to 0. So you see here they're putting 0 for the output and then solving for x. How are they doing it? Well, they're factoring out. Here's our common factor. Greatest common factor is x. So they factored it as x times x minus 5, and they thought what would make this function turn into 0 is if x is 0 or if x was 5, because 5 minus 5 is 0, right? And then there's a check. Then there's a check, okay? So there's a couple more for you to do. Pause the video and work on those. Another one. Another 2 more. Another one. Another one. All right, special products. Well, it turns out there's a couple of special products. So I'm gonna actually, I think what I'm gonna do here is let me close out that. I'm not editing this anymore. I'm gonna use this. I'm just gonna describe this real quick, okay? If I had, let's say I had A plus B, and I was going to multiply it times A minus B. So now I've got, and I wanted to FOIL this out. I'd have A times A would be A squared. And then A times negative B would be negative AB. And then A times positive B would be positive AB. And then B times negative B would be negative B squared. So what's going to happen to this part in here is that it's going to always cancel itself out. So then the result is that A squared, it would be A squared minus B squared. Okay? So this is called the difference in squares, right? Perfect square minus a perfect square is the difference of squares, right? Here it is, the difference of two squares. And whenever you see the difference of two squares, you can take the square root of one and the square root of the other and set them up in this form right here, right? So that you have an A plus B and A minus B. So let me give you an example. I'm going to try to give an example of each term. So it says difference of two squares. So let's say, what's a perfect square? 9. And what's another perfect square? 16. Okay, so if I have 9 minus 16, and I said, how could I factor that, right? How could I factor that? Well, I take the square root of 9. I'm going to do this in another color here. Here we go. So I think to myself, this is a perfect square. What's the square root of that? That's 3. And what's the square root of 16? Right? What's the square root of 16? Well, that's 4. And because these are two squares that are perfect squares, and I'm subtracting them, I know I can set and go 3 plus 4. Okay. And I can go 3 minus 4. Should be a parentheses here, right? And we're multiplying. So I just take the root of the first, the root of the second, and I set them separately, right? Perfect square trinomial. Okay, so a perfect square trinomial is where we have a perfect square at the beginning and at the end. All right, so you would have something like x squared plus, let's say, 8x and we'll say plus 16. All right, now I recognize a perfect square in the beginning, a perfect square in the end. And I think to myself, what are the square roots of x squared? Well, that's x. And what's the square root of 16? 16, that would be 4. And so now I think to myself, this middle term is positive 8x. So that tells me that I'm going to be getting 4x twice, right? So I would just have x plus 4. And so what we're going to do is we just put it together and square it like that. Okay? And the reason is when I FOIL this out, x times x is x squared. 4 times 4 is 16. And then when I do my outers and inners, I'm going to get x times 4 is 4x, and 4 times x is 4x. And together you add it up and you get 8x. So the only question is whether or not this is positive or negative. If this was negative, right, then you would have minus x minus 4. So let me try this like we did with the a-b thing a minute ago. Okay, let's just do it using a and b real quick. So a perfect square trinomial is going to look like this. It's going to be like a squared, okay, a squared, and then we'll just say plus 2 a b plus b squared. Okay, so that will factor down to a plus b, and then square. So let's try an example where a is, let's just go with x, and b is, let's say, 9. So then you would have x squared plus 2 times x times the square root of 9 is 3. So 2 times 3, that'd be 6x, right? 6x plus 9, right? So x squared plus 6x plus 9 would be the original perfect square trinomial. And then when you take the square root of that, you're going to end up with x plus 3 squared. Okay, you've done a lot today, and I don't want to get too much deeper into this. You can do the same thing if you change the sign to minus right here. If this becomes a minus sign, then you just change it to minus right there. And that's probably enough, like, for today of getting into the detail of this. We don't have to worry quite so much about special products right now in class because we know how to factor the expression without having to rely on those patterns. But it's good to be able to learn to see those patterns, and we'll talk more about them on Tuesday if we have the time. For now, we're doing these so that it becomes easy to factor. But if we're using our calculators to help us factor, it's already easy to factor. So I'm kind of not going to spend more time on this right now, okay? But here you see perfect square minus perfect square, so square root of x squared is x, square root of 25 is 5, and because it's a difference of squares, I go x plus 5, x minus 5. And, alright, that's a difference of cubes. We're not going to get into that, and sum of cubes, but you can factor these out completely. Let me show you exactly how we're going to do that. So I would go like this, menu, algebra, factor, and just put it in there, x cubed minus 64, and you're going to get x minus 4 pulled out, right? Because it's the cube root of x cubed and the cube root of 64, and that's 4. 4 is the cube root of 64. So you get x minus 4 factored out, and then when you're left with is a perfect square trinomial, x squared plus 4x plus 16. Okay. And same thing here when you go menu, factor. And then, of course, you can continue to factor that, right? Sorry. But you can continue. You can do a menu, factor that part, and just factor that perfect square trinomial, which was x squared plus 4x plus 16. And actually, that doesn't factor anymore. Sorry about that. You can't. So anyway, but that's how you can factor it, okay? And then we have, you can factor x cubed plus 27. Plus 27. I was thinking of x squared plus 8x plus 16, which would have been factorable, but okay, and there you have the same thing where the x comes out as positive, you end up with x plus 3, and then what's left is x squared minus 3x plus 9. Here we have a perfect square minus a perfect square, so m plus 10 and minus 10. Just take the square root of both sides and have a plus and a minus. Okay, so you can practice all these. You can practice factoring them all the way down. So depending on time, how much time is left in the class, let the teacher decide whether or not you have time to factor them. And now we have the roots. Once this has been factored, it's easy to find the roots. How else can you find the roots? Well, I'll let you figure that out. Okay? There's some more practice there. Pause. And practice factoring these out. Now, if you guys have been working your way through this video, and this video is over 50 minutes long now, if the kids are like, oh, I'm done, I can promise you they're not done. But if they are, go back, find a spot on the video where there's a whole bunch of these factorings to do, pause it again, and make everybody show you that they're done. Because as much work as we've seen in this video, plus all the time that I've been talking, it's going to take them a long time to get through this. Okay? This is, by the way, that's a perfect square and a perfect square. Don't miss that. See, this is 9. That's a perfect square. X squared. So this is 3x times 3x. And now we have 1 is a perfect square. 1 times 1, right? So, okay. Perfect square, perfect square. Think about factoring out 8 from this. You get x squared minus 6x plus 9. And 9 is a perfect square. And x squared is a perfect square, and you have minus 6x, so this should be 8 factored out, and then you'd have x plus, let's see, x minus 3 squared, right? Okay. And that is enough for today. Okay, we're getting near the end of this unit, and we'll have to finish it up on Tuesday.